All right, so here's another common question, especially with drivers, just give you an idea of what it takes to react. All right, so as you're driving at 30 meters per second, when you see the traffic light turn yellow, you immediately, and it's in quote unquote, react. Okay, so the average reaction time for a person is about zero point 0.7 seconds. It's actually much lower than that. I guess the author of this problem just decided to go at zero point 0.7. So you immediately hit the brakes, causing the car to accelerate at a constant 7 meters per second squared. So note that you are slowing down, okay, which makes this a negative. And so part A, how far you travel in that 0.7 seconds. Once you start braking, how long in seconds does it take for you to stop? And then what is your total stopping distance? So we're going to break it up into 3 sections. Now understand that some of the parts may go into the next section. Okay, so as we go, all right, so we're going to write down our strategy. So we're given the time, 0.7 seconds. We're given the velocity. In fact, part A is pretty easy because it's just simply v equals x over t, right? We have no acceleration. We don't have to worry about any of that, so we're just going to do our traditional x equals equation. And so we're going to do 30 times 0.7, which is 21 meters. Okay, and that's important because that's going to be part of it here on this side, because the way it works is this is your reacting time, which will be 21 meters, and then this is your braking distance, right? And so our total is going to be the summing of those two values, okay? Now, once you start braking, how long does it take for you to stop? Here's where we actually use our strategy. And so we have initial velocity of 30 meters per second. Our final velocity is 0. Our acceleration is negative 7 meters per second squared. And we'll actually calculate that. This is on a dry surface, and we'll do this calculation to figure out what A is equal to on various surfaces, so you can see how long it takes to go. We need T, and we don't care about delta X yet. We'll finding phase, we'll care about it over on the other side, but not this part right now. Okay. So now we have our 4 equation, or our 4 variables. So we're just going to do our first equation, that V equals BO plus AT. Solve it for T. Again, we can kind of do some canceling. That's just 0. So T is going to be negative V0 over A. So that's going to be negative 30 over negative 7. Right? So negative 30 comes from the negative sign. That negative 7 is because you're slowing down. And so that's going to take us roughly 4 seconds or so 4.29 seconds. Okay. Now we're going to figure out the braking part over here on the right-hand side. So we need to figure out how far does it take for us to brake. So we would have these same variables, but now this is our question mark. So our delta X is now our question mark. Right, so we would have the 30, we'd have the 0, we'd have the A. Now we would have T, but we don't have to account for it because maybe this is a scenario where maybe that one's wrong, where now we can just keep this by itself. And so we're going to use the V squared equals VO squared plus 2A delta X. And we're going to solve this for delta X. And again, we can do some simplifying. So that's going to be 0. So that's going to be negative VO squared over 2A. Right, and so it's going to be negative 30 squared over 2 times negative 7. And so you're going to get 900, because that's what 30 squared is, divided by 14. And you're going to find that it takes 64 meters to stop, okay, while you're braking. So that's our braking distance, right, or our braking time. And that tells us it's going to be a total of 85 meters. Sorry, I panned all of a sudden. Don't know why I panned. Okay, so it's going to take us 85 meters to stop.